everybody, welcome back. We're here at the Engine Performance Expo, and we've just been running the gamut of all different subjects. Lake doing a great job. You know, oil is something he knows a little bit about, but now we're going to dive into custom parts manufacturing. See these Rottler machines? That's really what it's all about. And Cass Coate is with me. Cass, Choate Engineering, that's really what you guys do. You find a need, you dream something up, but then you've got to make it, something that's much more possible nowadays than it was, say, back in the day.
Absolutely. Well, they say necessity is the author of invention. So with the tools that we've been given nowadays, it's an awesome thing to be able to think of something in the morning, create it at night, have the program written, and try it on the truck, you know, the next day and see how that works. So
you guys doing a lot of diesel stuff and otherwise. Yeah. And the way you just said it is just dream it up, write the program, and next thing you know, it becomes a reality. But there's a lot of elements involved.
Absolutely. Yeah, the limiting factor is definitely your imagination, and that's the cool thing about it. There's a lot of elements from the design concept that you're, first, you know, the thing that and I'm an avid reader, and one thing that I love to see is guys that are inventors, the first thing that you have to come up with is a problem. So everything starts with a problem. Once you've got the problem, and then you start thinking about the solution from the CAD CAM software side of things, that's after you've got it kind of niched out in your head how you want it to work. You can simply go straight to a Rottler machine like this, or a laptop, or whatever it might be, draw it up in CAD. You can, with the technology as advanced as it is today, we can take that part, bolt it onto the concept, see if it fits, check fitment on it. Once all that's said and done, write a tool path, program it, put it in the machine, and that's kind of the order of events to take place.
And it's been amazing to see, at least for me, how that process has been applied to so many different areas and avenues of whether it be race engines, cars, chassis, suspension, and otherwise. There are many people like yourself just attacking these problems, but right. It seems like the problems, we keep finding new ones.
That's it, and that's the common denominator. It doesn't matter whether you're in the medical industry or you're in the racing industry, the common denominator is the problem, right? So that's what the origin is, and everything kind of circles around about it. There's a lot of things going on today. You know, when you've got equipment like this, and it's an expensive investment initially, it definitely pays. There's a huge return on investment. If you're busy in the shop, you keep this thing going, automate, you know, don't populate. That's kind of the concept behind it. But you want to squeeze every drop out of that lemon you can get. So with a machine like this, you can take and you can actually program not just to do engine machining, but now to do part manufacturing. So that makes it so much more worth the while.
All right, so for everybody out there, we're about to go to a video, and Cass is going to be in the video. It's going to be all about what we have spoken about. But then on the other side, we're going to come back, and it's going to be your time for questions and answers. And I know you're getting a lot of those on a regular basis all the time. You know, the average person out there doesn't even know this world exists for the most part, but they know their problems are getting solved one way or another. It's got to be a little bit of a source of pride to be involved in that whole process.
Well, it's nice to be able to dream up and be able to take your personal thoughts, make them see the fruition in the development to actual reality. It's very satisfying to have a problem, but be the part of the solution to the problem.
Yeah, and it doesn't always happen on the first try, I'm
Never.
sure.
No, rarely.
Well, excellent. I'm looking forward to it. We're going to kick it over to the video, but don't forget, on the other side, we're going to be back with a question and answer session. So watch the video, let your curiosities run wild, and we'll answer those questions on the other side.
So behind me is just another example of what we do here at Choate Engineering Performance. So we've got on this Rottler F69 ATC loaded up is a piece of 4340 billet that we are going to be machining some main caps for Duramax diesel. Now the Duramax is plagued with the crankshaft issues, the failures of crankshaft, and we know that through the Cass cap there tends to be a lot of fretting. Everybody likes horsepower, and nobody likes to tune more than the diesel world. Every diesel owner seems like, I would say 80% diesel owners, they've got some type of tuning device on their truck. Everybody loves the torque that they provide, the horsepower, the fuel mileage, the fuel economy obviously, and the longevity that it provides. So we look again at those problems that are from certain platforms. The Duramax definitely is a fantastic platform, but there's one area of weakness in it, and the main caps, the fretting from the main caps from additional horsepower that's added can lead to crankshaft fatigue and failure at sometimes. So what we've done is we've designed some billet main caps for the Duramax diesel. Now this is all the way from 2001 all the way up to present day. So let me show you what we've got going on here. Again, the reason why we invested so much in the equipment that we have is because of what it allows us to do. I'd like to show you a few of the very unique functions that Rottler has in their wheelhouse, and it makes our job so much easier. So let me show you those now. Behind me you'll see a program, a software that we've got pulled up, and it's called Fusion 360. Now this software is by Autodesk, and it has really came to fruition the last few years. It's fantastic because it does two things. It allows me to do CAD and CAM. Now for the guys that don't know what that is, CAD is what's known as computer-aided design, okay? So what that means is before I can actually make that part, I've got to make a model. So I know what the end representation of what it's going to look like, right? So you can see on the screen here, here's a billet main cap, okay? So we've taken this through the CAD side of the software, which we can click over here and go into design, and you can see that through this timeline where it starts. And I'm just going to play through this so that you can actually see me build this main cap right here. And this is how we modeled this up. And once this is modeled, we can take and we can finish, we're done. Now that we've got this modeled up, we're going to go ahead and move over to the manufacturing side. Now this is the CAM side. Now what CAM stands for is computer-aided manufacturing. We have to be able to draw some type of tool path and able to achieve the end goal, which is to make the part. But there's a lot of things. In days gone by, people would use what is known as G-code. It's cumbersome. For those that aren't familiar with it, it can be hard to learn. The Rottler block software makes it extremely easy for guys that aren't necessarily engine machinists, but not what we would consider a G-coder. It makes it very simple for them to be able to start to finish instantly kind of jump in there, because it's what we know as conversational programming. It asks you something. What would you like to do? How would you like to do it? You know, from this point to this point, and it walks you through in a very conversational type manner. The CAD CAM software with Fusion 360 allows us to do more dynamic milling, meaning it's not so straightforward of type machining where we're moving in a linear fashion in a direct motion, but sometimes we'll have what's known as maybe torquedoidal machining, which is where there's rapid movement within the machine to move as much material as we can, as quickly as we can, to get it off the part. So instead of trying to draw all that out, it would be an absolute nightmare. You'd have thousands and thousands of lines of code, but we can do this through this CAD CAM package. Now what really makes this unique to Rottler is the fact that, you see me, I'm sitting at this machine. I don't have to go anywhere. I don't have to have a laptop that sits in my office or bring it out to the nasty shop and go in and try to do all this modeling and everything that you see, and then load it to the machine with a thumb drive, and then from there have to upload everything. I can actually make changes completely at the machine. If I decide that bolt hole isn't exactly where I want it, or that model is not quite the way that I had intended it, I can do the modeling here, and then I can transfer it over to the CAM, and just as easy as that, I can open up the RCAM software and import it, and now you see the toolpath through the RCAM software right here, which is really neat because you can see the end mill, and that's actually where the end mill is right now on the table, which makes it really nice to see how that's going to play out for me. If my clearances are where they should be, if there's going to be any type of crashes or anything like that, I can already see that before it ever happens. So that's something that's very unique to Rottler. We've got other machines in the shop that don't have this capability. It's just a controller, but it's not a conversational controller, and it's not a one-in-all type setup. There's nothing more valuable than your time. You can obviously make more money, but you'll never make more time. So being able to have things that allow us to save, that are time savers, save our lives, if you think of it that way. Going back and forth and having to retransition is something else that you're not going to only see here. We'll show the same thing with the Rottler porting software. Having it all in one and at the controller, at the machine, means that if there's a problem, everything, my whole office is now consolidated to this machine. Where I sit right now and the computer that I use right now, this is my entire office. There's nothing outside of this footprint that I need. So it saves us a tremendous amount of time from transitioning from moving a file from one computer to another computer, but to have this all at the machine that we are operating is a tremendous amount of time savings, which means more profitability for the end user. So you've got a CNC machine and you've had it for a while, or maybe you just made that purchase, but you really don't want to delve off into the CAD/CAM side and learning how to program. It's too much and it's a little scary. It's no problem. You don't have to quit there. You don't have to call it quits. Give us a call. We can help you. What we do is allow you to send us your projects, whether physically, mail them to us, or you can email them if you have a file or anything of that sort, and we can write the programs for you. So that all you'll have to do is load the tools, load the material, and load the file that we send you, and you'll be able to manufacture the part on your machine, in your shop, at your leisure. That's another service that we provide to our customers, programming so that they can make sure that they're making the most out of their equipment.
The Rottler, in the innovative way that it does that, offered me something that I could have one person doing two jobs in the aspects of what the machine's capable of doing.
I notice you've got a pretty unique part in this machine right now, so can you explain just a little bit about what we're doing here?
Yeah, we've got a unique situation. We've built a relationship with Nathan Higgins over in Australia, and Nathan and I have been talking for several months now, and he had developed a program for porting the LSA blower manifold on the GM cars and stuff. Now, because of logistics, especially because of the COVID and the pandemic, we've actually experienced shipping delays of up to 3 months. Stuff that we've shipped has taken 3 months to get to Australia. So Nathan has an EM69. In fact, he has 3 of them. So we were able to download his programming onto our machine, and we had talked, there was some finishing that he needed to be done on the intake manifold as far as blending, that when it came off his machine needed to do by hand. Well, with the capability as far as the talent that we've got here at Straub Technologies, we were able to blend it, digitize it, and then redo the program as far as doing the editing on it, so that now since we've sent the program over to Nathan, he can now port a blower manifold, and when it comes off the machine, it's ready to be washed and assembled and put in the box. There's no hand blending whatsoever. So the uniqueness of the machine being here and over there, and the software that Rottler provides, it makes life very simple for us. But yes, so we are one of the few people in the United States that ports the GM blower manifolds, and we're proud to say we do it on a Rottler EM69P.
I like the versatility of the machine. I mean, you can digitize, get your ports ready. It's very simple and pretty straightforward to edit ports, change your shapes, you know, change tools. It makes everything pretty quick and simple if you want to make changes to whatever project you're working with. You also get the sides you can make parts, so you're not really limited to anything with this machine. Today I'm giving it the first go on porting this LSA blower manifold. We had it sent in from a customer and we re-digitized after doing some hand blending, and this is the first test run of the port job we're putting into it. This being such a big port, it's actually in two separate pieces. So if you take a look at the screen here, I've just got it labeled as left side and the right side. So instead of actually getting to start from like a seat side on a normal port and go all the way through to your dividing section and come in from the other side, I've actually had to start from where the snout of this blower goes, go down to where the rotor machining starts, and from there the port's actually divided into two pieces. So kind of makes it a fun little job to get everything to blend in nicely, but it's not too bad. It took a little bit of time. I had to spend some time on detail to get all the data I wanted captured, but the machine makes it pretty straightforward with doing stuff like this. Everything that's in the porting software, every bit of that was done on that. There's no help from any outside sources with it. Yeah, we'll go ahead and let it start. It's gonna start on the right side of this port, and it'll go all the way down, then it'll work its way and start on the left side and get everything blended in. What you see on the screen is what's actually going on in the machine. So you get to, you can set up renderings of the tools into this machine. So whenever it's running, it gives you an actual, I guess, an idea of where you're at in the port. So a long port like this, you know, you can kind of see exactly where it's cutting instead of having to reach over and look down inside of the part. You can see that with that model, and you can go to the toolpath page on the software as well, and it'll show a solid model of the port. You can actually see everywhere the tool is going to be in that entire tool path. So if you see it start hanging outside of the port, kind of gives you an idea so you can start pinpointing where your issues will be at. You can get almost nearly perfect with this, with the renderings and the software, so you don't have as much as a worry whenever you run something for the first time.
Hey, thanks for joining us for a quick demo. I'm Ryan. I'm here at the Rottler factory in Kent, and behind me is the EM69 HP. This is our blockwork and porting machines. If you take a look in here, we got something unique set up here today to show some of the multi-axis, specifically 4-axis machining capabilities we can do. We have our adapter on here for a 3-jaw chuck, which lets us put, as you'll see, a crankshaft or any cylindrical object you wanted in here. And over here we have our Rottler 4C software. It's what we've used to import a step model of a crank that has the features we want to machine onto it. And just to give an example, we're here on, this is Callies crankshaft. And the feature we're going to be doing today for this demo is they have, I believe it's called an arrow wing, or basically just a profile on the counterweights. Those counterweights, we just want to profile it back. on the leading and trailing edges. And like I said, we made a model and we've imported into our software. And what that lets us do here is we have these relieved features and we put some toolpath on here. It's going to allow us to go down and kind of profile back the edges on here. Now, programming this, just to talk a little bit about how easy it is to do inside Rottler and the 4C software, is for those who've never approached multi-axis or thought about doing, you know, an index setup on a milling machine, it's really easy. It's really easy, especially once we have a step file. We can import that in. It has our features we want, and you can see I've already built this one out. I'm going to highlight this first profile that we're going to do here. And basically all we do is, once we have that, we know what we want to do, and we can adjust that model. We just select the edge on the model, where we want it to start cutting, where we want it to end cut, finish the cut on the depth, and we basically set up some step overs here so it doesn't cut the whole thing out at once. So you can see here on the visual, and we can even simulate this, which is really nice. We can drag this along and see our tool in there, just stepping down, going over. And like I say, this is all inside of our Rottler 4C. We're on our EM69 HP. We're going to use the 5/8 ball nose end mill to go ahead and profile these counterweights. And we'll go ahead and hit cycle start on this. Like I say, we'll let that run. When it's finished up, we'll splice in some of the video from the internal machine, and we'll catch back up at the end of this, show you the finished results. And yeah, thanks for tuning in and being with us today. back here at the EM69 HP. We just finished up machining that crankshaft in there and profiling those counterweights. And we got the model here, program's all done. We're gonna go ahead and open it up and take a look and see how it did.
Hey everybody, welcome back. Joe Castello back with Cass Coate. We got Jaden in on the deal, and we just watched a video where, Cass, you were in there. We're talking custom parts manufacturing, and I just want to make sure everybody knows now is the time for your questions. We're gonna put these guys through their paces a little bit. We got Warren Johnson coming up in a little bit, so stick around. Going to be a whole lot of fun. And I know there was a quick question out there about accessing yesterday's programming. It's right there in the nav bar on the side of your screen. You can access everything we did yesterday. But don't go anywhere. Stay live with us for a little bit. All right, so we just watched the video, and the whole concept of taking something from problem to solution. Right. Jaden's just 21 years old. We gotta introduce him a little bit, though, before we get to your questions. Jaden, 21, you're running machines. You're going to be running a machine with a professor of Pro Stock, Warren Johnson, here in a little bit. How did you get into all of this?
My interest really started in high school. Always liked vehicles, needed to make the parts for the vehicles, so I kind of took a machine shop class, and my teacher kind of forced me into the CNC side of things. I didn't really have a choice, and then I just fell in love with it and took off from there.
So there it is. You were forced and you fell in love, and the rest is history. And we've been hearing all morning that there are some shop teachers out there who are showing this programming to their students, and the students are now watching throughout the day, so we encourage that. Cass, we're going to ask some questions from people, so put them in the comment section. But, you know, what was your introduction to all of this?
I had what I consider a backdoor education. It's a long story, but my truck broke.
Oh, there it is.
That's basically the way that you know, again, like we said, necessity is the author of invention, and just having problems and not having the money to pay for them, that causes you to figure out ways for solutions. So one thing kind of advanced to another, and you know, we had trouble finding good machine shops where we were located, and you know, the next thing you know, you become the guy that has to do to fix the problem. So that's kind of the way that worked out. And
a problem solver. And for those of you, we also heard some people suggest some audio issues. Obviously, make sure you're unmuted and crank it up. And we're in a shop here, so we're doing our best on our end, and we're trying to make sure you guys can all hear. All right, let's get some questions going up. And I know we're talking about these machines, Rottler in particular, and so some of the questions you guys may be able to answer. If not, we'll go into another arena. But here's one about like proprietary software. Do you guys know, does Rottler require proprietary software to create cut files? Does it have IoT capability? Is that something that you have the answer to, Cass?
So Rottler does have proprietary software. So the beauty of it is, in the 5-axis porting software, there's not a better software on the market to go from digitizing to creating a toolpath. So that is a proprietary software that they use. Also on part manufacturing, they do have the ability to import, as we showed on the video. There's a post-processor that's available for Fusion 360 on the Rottler machines, and they're working to develop more of the 5-axis stuff right now, but there's post-processors available that you can download straight from Fusion onto the Rottler machine and be able to make a toolpath.
Excellent. Waiting on some more questions. Here's like a half one from Adam. Can you turn the OD on counterweights with and he didn't quite finish his thing. Can you advance what he is trying to think regarding counterweights? There's a couple of comments about counterweights maybe being on the wrong side in the video, maybe a little confusion. Can you try to clear that up as best as you can?
The manipulation of the counterweights, anything that in the 4C software, If it can be modeled, as far as the machining side of things, you can manipulate the model any which direction that you want to on that. 4C gives you those capabilities. It can be done through there, and it can also be done through the software, like we said, through Autodesk.
Now, Cass has been around for a while. I've been around for a while too. Jaden, just early 20s. You don't know a world where this stuff didn't exist. So that's kind of pretty amazing. What impresses you about this machinery and your ability to take an idea, solve a problem, and turn it into a reality?
The simplicity. I mean, even me working with Haas machines coming onto this thing, I mean, it didn't take much time at all to be able to figure it out and manipulate things and doing everything exactly how you want it to.
Well, exactly. Someone asking, will the question and answer sessions be available? Yes, it'll. I believe it'll all be available, and you'll be able to chop it up and look at it and see it and everything. Here's one, and I guess this depends on what you want, but approximate base price is a question that people are getting. Like, how much investment to get started, which is a good question. That means they are already thinking about what they're going to do with it.
Right. My suggestion would definitely be to contact Rottler and speak with them. The great thing about Rottler is that they're not. They have individual reps that go around through parts of the country, and they're willing to come by your shop, spend some time with you, find out what you're doing, and kind of custom tailor whatever equipment that you might need to suit your part that you're manufacturing, or whatever type of work that you're doing. Again, something that we didn't really touch base on. Keeping in mind, you're a lot of times trying to retrofit something, or you're trying to take apart and make sure that it'll fit over here. One thing that Rottler does that makes it really nice is and I don't know, I know that we recorded a segment on this. I'm not sure when it's going to be shown, but digitizing, say you have something that you want to reverse engineer. You've got to figure out what the shape, the geometry, the dimensions are on that thing, and then be able to model it. Instead of just making something right off the top of your head, you can actually use this software to digitize, and that will give you what's known as point cloud data, kind of like the porting software showed. I know that Jaden, there's a part in the show that showed digitizing port. It's also possible to do that on parts as well. So if you have an outer profile or a 3D part like that, and you can digitize, then you can create what we call a step file or a STL file from that, and import that into the other software.
I'm already sparking. There's been a million times where there's something that's like, that's pretty good, but with a couple of additions, modifications, it would work perfectly. Mm-hmm. And you just got to add to it. So I like that.
Yeah, it keeps you from having to purchase a 3D scanner. And then not only that, the CNC machine or the software with it, it's consolidation. And that's the thing that makes, like Jaden was saying, that's what makes it so nice, is the ability to consolidate and make an investment, but not get so strung out with so many different, now you've got to learn how to use a 3D scanner. Now you got to learn how to, run GeoMagic X or whatever it might be. And you can do it and learn one software, and that makes it a lot easier.
Excellent. Jaden, can you share a story where you were challenged to create something, and it was a genuine challenge, like maybe you didn't know how you were going to get to your end point, but you came through on the other side and it worked out?
I guess my most recent example is actually my personal truck. It's a 6.0 Power Stroke. People have their different opinions and stuff about it, but I had to. Yeah.
There's one.
Thanks.
You found one.
I had to change the rod bushings in the rod, and both ends of the rod actually are tapered, so there's not an actual flat surface you can ever press on. So it took some thinking and I guess a little bit of processing to do to figure out how I can make my own tools to get that pressed out, get a new one in, and cut it back down to the size.
So you had a problem, you made the tool to solve the problem.
Yep.
You didn't make the part, you made the tool to solve the problem, and that's what it's all about. Here's a question from Joe out there. Joe, thank you very much. Can Rottler import G files that are used on the Haas, was the question.
You want that one? Or?
You can go for it.
Okay. Yeah, there's a G-code editor with Rottler. You can actually open up in the RC or RCAM or the 4C software, and there's a place in the toolbox that you just will go through. It's called G-code editor. But anyways, you can open that up, and it will translate all your G-code files to basically, it can read G-code, and it can work off that. So that's no problem whatsoever. It can definitely do that.
Comment from Rudy out there says, you guys are so high-tech. Do you view yourself as extremely high-tech?
You ask my wife, and she'll tell you I can't run the, I would say VCR, but that's above the days. Mine is still Lincoln 12 o'clock. I can tell you that right now. No, I don't consider myself high tech. Again, I don't try to cover myself with things that aren't pertinent to my happiness. This is definitely one of them. This is something that I deal with every day, and I love doing it. As far as anything else, I would definitely not consider myself high tech. I think that I give ignorant people hope all over the United States when they see that someone as ignorant as myself can take this and do something with it. So that should be a major encouragement to anybody out there listening.
You're joking, but that's important because people need motivation. Absolutely. Regardless. And there are people with shops, with space that are thinking like, maybe I should, or I can't learn that. I can't learn something new, but they can.
Yes. The thing that people don't realize is what's done today in our industry, not just our industry, but industries all over, is really and truthfully, it comes down to it as there's nothing special about it. What it is a person that's through desire, they will stick with the problem and figure it out. There's a lot of support too. Years ago it was you have to buy this book, go to this class, travel all over the country to learn how to do this. Well, people, we are in the information age. However, we've got a lot of people that have no information on anything. It boils down to it, and I think of the verse that says, "Wherefore is it the price of a handful to get wisdom, seeing he hath no heart to it." If you really desire to know something, there's enough resources online to teach you how to do what you want to do. Goodness knows, people are building houses and doing things off of YouTube now that they never had before. It's insane the amount of context or the amount of information that's out there.
All right, here's one from Jason. Jason, thank you so much. On a typical LS cathedral style head, how long does it take to digitize and duplicate a port design? There's one for you.
Start to finish, I guess intake port, exhaust port, and a chamber. I mean, I spend about a day, roughly about a day's work. You can get it completely digitized, edited. First thing that next morning you can be running it.
Okay, there you go. And he even said start to finish. That is a great question. Keep them coming. We got a couple more minutes. Can you modify this from Nicholas? Can you modify port geometry with the Rottler software, or does it only duplicate / copy the existing port?
I'll let you take that one.
No, you can change the port, intake, exhaust, chamber, any way that you want. As you go through the port, you create planes that the probe actually touches as it goes around in a closed section, and you can change any of those points any way that you possibly want to.
Wow. So if there's a part of the port that you really like, but there's another part that you'd like to put your own spin on, you can do that.
Change it, you can smooth it, you can put in bolt holes, you can enlarge sections, shrink them, and it's easy. Just a click of a mouse and you can do it.
Amazing. Amazing. Cass, what about you? A challenging moment where you maybe bit off more than you could chew, but you ended up on the right side?
Oh man, there's so many of them. I think everything that I do is a challenge that I end up on. I guess some of the big struggles that we actually have incurred lately have been ways to address certain insufficiencies in engines. We're known for the 6.4 liter platform for sure. I jokingly, say I'm sorry about the 6.0 power stroke. But the truth is I don't know. We've spent so much time with that. They call it my mistress engine because I just won't leave it alone, and I keep trying to make it better and better and better. So the 6.4, we've developed oil rail systems for the rocker arms, and really trying to get that just how I want it, the fitment, just how I want it, but the functionality. Our goal is, this is something Chrysler used to say, fashion by function. So there's a lot that goes on with the parts that we make for the just something as simple as a valve cover that has an oil rail system that goes through it. So that was a long time process for us, and it took us almost a year to get it to the point where we were really satisfied with everything and the way that it worked. So, but in the end, it was definitely worth all the effort.
Well, excellent. I appreciate it. Thank you guys for spending a little time with us. Jaden is going to head over and start warming up a machine. We've got a big surprise a little bit later. Jaden, thank you very much for spending some time. Cass, great job with Choate Engineering and digging in with a little question and answer. These guys are going to exit stage left, and we're making a call to the bullpen, right, to come in and finish the game. What a day, what a day, what a day. Yeah, my brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.